am Sofia Werner from SSPA, and I will introduce the group discussion 1, full-scale prediction at highly varying drafts. And this work was prepared by the working group on parameters for full-scale power predictions. In the working group, we have 7 members from different ITTC organizations and 2 observers. I will first go through the background to the working group. In the famous EDI formula, which we all know by now, we have one component, which is a VREF. It's a reference speed. It corresponds to the contract speed in a builder's contract, and it's determined by sea trials. But VREF is calculated at scantling draft, or a full load draft. Similarly, the contract point in a builder's contract is derived at design draft, but most sea trials are carried out at ballast draft. So for practical reasons, that is that most sea trials are done at ballast draft, apart from tanker vessels. So to convert the model test at ballast draft to the deeper drafts, we use model test curves at design, or the deeper draft and ballast draft. The model test curve at ballast draft is very well validated from decades of correlation, giving correlation factors. The correlation factors are, for example, CP, or most common is to use CA. But at the deeper drafts, design or scantling draft, the predictions are less validated due to the lack of sea trials at design draft. And this causes a large uncertainty. And let's see here if the model test design draft curve is shifted because we use other correlation factors. Then the derived reference speed will be different, even though we have exactly the same sea trial result. There's been some comparisons done between various model test facilities. We all know the ITTC inter-tank comparison campaign at model scale, and result in very similar values at model scale. We also know by experience that if we compare full-scale predictions at ballast draft between different facilities, they're often very similar. But if we compare results for deeper draft, design draft or scantling draft, sometimes there are large difference between the different test facilities. At ballast draft, we have very well validated correlation factors based on many sea trials. But at the deeper drafts, there are not so many sea trials available. And this is what causes probably the large differences between the facilities. So to summarize the problem, sometimes we see a large difference in model test predictions at full load draft between different test facilities. And this affects the derived speed from the sea trial. And the consequences is uncertainties in the EDI value, and that can give false results and unfair competition. And it's something that we need to address. The solution to this, we know that at ballast draft, the test facilities have trustworthy correlation factors. So that's not a problem. But what ITTC needs to assist with is to derive trustworthy relation between the deep draft and trial draft. So that's the relation between these two drafts that ITTC need to assist with. Therefore, ITTC Advisory Council established this working group on parameters for full-scale power prediction in 2020. So what does IMO say about this? Since it affects EDI, IMO identified that there is could be a problem with the curves from sea trials. And furthermore, in this document from IMO, it is suggested that the verifier should compare the difference between experience-based coefficients between the different drafts. And an example is given here where the relation between the correlation factor CP is given in a graph. ITTC procedure for speed trials state that empirical coefficients shall be, for all drafts and trims, the same empirical coefficients shall be used. Here we have discussed various solutions to this problem. First, should we require that all towing tanks use exactly the same evaluation procedure and coefficients? And we come to the conclusion that no ITTC members do not want or to do that. They need, for various reasons, to keep their tank-specific method and coefficient. Mainly to keep their historical database continuity. Should we require that each tank correlates their predictions with sea trials at full load draft, so design draft or scantling draft? That's not possible, as we have seen that there are very few sea trials available at deeper drafts. Should we require that each tank correlates the data from operational data instead at deeper drafts? That is not a good solution either, since we know that the operational data has very large scatter. And one can draw any conclusion based on that. So should ITTC stipulate a fixed difference between correlation factors, as was suggested in this IMO document I mentioned? Like a delta CP. Is that a solution? That was investigated in the previous ITTC period by Specialist Committee for Performance of Ships in Service. And it was shown that it's impossible to derive such general delta CP. You can see the details in the committee report from that committee. But in short, the committee tested to derive a delta CP for a test case with 3 different facilities. And you can see here that the delta CP that they derived ranged from -0.5 to 0.1. So this is simply not possible. It's too tank specific. So the last solution is that ITTC provide some kind of template, and each facility must demonstrate that their methods and correlation factors result in reasonable relation between the power at deep draft and ballast draft using this template. And this is the solution that the working group have continued to study. And what is this template? One way to express this template could be that ITTC provide a template ship, meaning model and full-scale data for an example ship. And then each tank or verifier check that the method and correlation factors give correct results against this template ship. And again, it's only the relation between the power at design draft and ballast draft that we are looking for, not the absolute value. The second method is that ITTC provide a template method instead. And each tank or verifier check the output from each project against this template method to check that the relation is reasonable. But then we come to the problem, how should we derive this template method, whichever it is? And the working group will follow this work. First, we'll collect full-scale data, preferably from sea trials at various drafts or operational data of high quality. And then start from an existing extrapolation method, for example, the standard ITTC-78 method, and check or tune that method so that it fits the data that we have collected. And again, only the relation between design and ballast draft speed curves. The working group has a list of terms of references, and we have now completed the first steps, and we have collected data for a number of ships, both from sea trials and operational data. And we will now try to start to analyze the data. The timeline is we have worked for about 1 year, and we have 1 year to go. And now to the group discussion. On Tuesday, June 15, there will be a group discussion. And in this session, we would like to discuss live topics like, do you share the experience that we have presented here? Do you have suggestions for how the demonstration can be done in practice? Or can you suggest another solution to the problem? So please be prepared with your comments and ideas for the group discussion. And I'm looking forward to see you there. Thank you.